Hello and welcome to Research Methods. In this unit, we'll cover hypothesis testing. There are three big ideas that we'll be going through with a series of videos from Crash Course on Statistics. The first big idea is hypothesis testing. We'll then look at p-values and we'll look at errors in hypothesis testing. The history behind hypothesis testing is how do we collect new data and find out something for sure? How do we achieve certainty and reliability from doing research? And there's a difference that goes back to Karl Popper, who was saying the problem with induction in science, that as we keep adding new data, do we get new information? Confirmatory data doesn't really add to anything in science. If we're testing the law that all frogs are green, we can have 1 green frog, 10 green frogs, 1,000 green frogs, 10,000 green frogs. We're no more certain. 1 blue frog or 1 yellow frog gives you new information because it disproves a hypothesis. All frogs are green, blue frog, bam, you've learned something new. So in hypothesis testing, we set up a null hypothesis and then we look for evidence to disprove it. There are a number of big pieces to the puzzle here in hypothesis testing. The first of which are the test statistics we use to test hypotheses. Hypotheses are evaluated using an objective set of standards. Those standards can be from the z-distribution, the t-distribution, the f-distribution, the chi-square distribution. We look for a test statistic that's unusually large. Right? So we disprove the null hypothesis if the value we see is freakishly big. So our test statistic is the value we're testing. It's like Goldilocks and the Three Bears. The porridge is too hot, too cold, or just right. Our test statistic is the temperature of the porridge. If that temperature of the porridge, our value of z or t or f is 200, 200-degree porridge is really crazy freaking hot. It's so hot this is not an accident. Someone did it on purpose. Right? But if it's 60-degree porridge, it's a little cold. 50-degree porridge, it's a little cold, right? 20-degree porridge, that's not an accident. Somebody chilled that sucker on purpose, right? Sampling error doesn't cause that. It was a systematic effect. So we look at test statistics. The next big thing in here are p-values. P-values are the probability something would happen again. I like to explain this. A p-value, you want it to be small. Very, very small. It's the probability that your effect wouldn't happen again. It's a measure of reliability, the number of times your car doesn't start when you turn the key. If it doesn't start 1 time out of 1,000, that's not bad. Right? Most of the time your car starts as reliable. But if your p-value is 0.4, your car doesn't start 40 times out of 100 or 4 times out of 10. That's not reliable. It wouldn't happen again. It's not a solid, stable result. The last thing we'll be looking at here is errors in hypothesis testing. If you decide that this was random and it wasn't a systematic effect, well, you're correct. So we'll be looking at correct rejections and false alarms in hypothesis testing.